Hey everyone! Today we're going to start Chapter 2, which is about matter and change, and we're going to focus on Section 1, which is about properties of matter. It starts off by saying, why are windows made of glass? Specifically in this lesson, we're going to learn how properties, which we're going to define here coming up in the next slide, can be used to classify and identify matter. Remember from previous lessons that matter is anything that has mass and takes up space. This is a lot of things in our natural world, including air, water, fishes, buildings, trees, and even us. Properties are defined as things that you observe or measure when you look at a sample of matter. Examples of properties can be like, is it a solid? If it is it shiny or dull? If it is a liquid, does it flow quickly like water, or does it flow very slowly like corn syrup? And if it's a gas, does it have an odor? Or if it does have a smell, is that smell pleasant, or is it very awful and you kind of want to plug your nose? Properties, again, are used to describe matter, and they describe matter in different ways. One of the first ways that we're going to learn is how to describe it, whether it's extensive or intensive. Before I go to the next slide and I describe each of these and give the book definitions, the easiest way to determine the difference between extensive and intensive is to look at the matter that you have. Extensive focuses on the amount of matter, while intensive focuses on the type. Extensive property is defined as a property that depends on the amount of matter on a sample. Two very easy examples of this is going to be mass and volume. Let's focus on mass first. The mass of an object is the measure of the amount of matter an object has. For example, if you were given a basketball and a golf ball, most of you guys realize that a basketball has more mass. It tends to weigh more. It feels heavier. Now, how is this an extensive property? Remember, extensive depends on the amount. So the more basketballs you have, the more mass you're going to have. So mass depends on how much is there. Volume, on the other hand, is the measure of the amount of space that object occupies. Again, the basketball is going to have a higher volume than a golf ball. If you have a closet and you're sticking 3 basketballs in a closet versus 3 golf balls, 3 basketballs are going to take up more space. The greater amount that you have, the greater the volume. Now, these two properties aren't the only thing that you can consider when you're looking at a piece of matter, such as a basketball. Other things that you can take into account is what are basketballs made up of? Is the outer covering leather, rubber, or some other synthetic composite? Each of these materials, leather, rubber, and other synthetic things, each one is going to have different properties that make basketball suitable for playing, whether it's inside or outside. This is an example of intensive properties. An intensive property is a property that depends on the type of matter, not on the amount. It doesn't matter how much leather I have, it's still going to have a certain property, such as absorbency. Absorbency is your book's example of an intensive property. Another example would be color or smell. It doesn't matter how much you have or the amount, it's still going to have that color and it's still going to have that specific smell. Let's focus a little bit more on the example that the book gives you. If we're looking at absorbency and we're looking at the type of matter, let's compare leather covering versus a rubber covering. Leather balls are often used to play indoors and not outdoors. The reason for this is leather balls have a higher absorbency, and so they're going to absorb that water and dirt that you pick up outside. This causes those basketballs to get very grimy and wear down, picking up smells, and oftentimes you have to throw those out. Rubber balls, on the other hand, do not absorb the water and dirt outside, and they're very easy to clean off. So these are the more likely choice to play outside. Here's our first checkpoint question. It says you want to compile a list of properties of substance, but you don't have a way to measure mass or volume. What kinds of properties can you determine without knowing the amount of matter in a sample? Remember, the two that we just learned about was extensive and intensive. Extensive depends on the amount, and intensive depends on the type. There are two key giveaways within these sentences. The first is you don't have a way to measure mass and volume. Remember, mass and volume are examples of extensive. So if you don't have a way to measure those, it's probably not going to be extensive. The other key giveaway is these are properties you can determine without knowing the amount. Since extensive depends on the amount and intensive does not, your answer here is going to be intensive. Now that we've covered that major difference, intensive versus extensive, let's look at properties when we describe them as either physical or chemical. Let's focus on physical first. And this part is going to be very important because you have a lab coming up where we're going to look at physical properties of different compounds and substances, and you're going to tell me what it is. So a physical property is a quality or condition of a substance that can be observed or measured, and it doesn't change that substance composition. In other words, its makeup. What is it made up of? Examples of physical properties include hardness, color, conductivity, and malleability. Hardness is how easily can it be scratched. You can scratch a desk and it still stays a desk. You can also look at its color and it's still going to be the same thing. You can test whether it conducts electricity or conducts heat and it's still going to be the same thing. Or you can check its malleability. So malleability is its ability to bend. Can you bend something? If it can, it's going to have good malleability, but it still stays the same thing. If you bend iron, it's still iron. Here are other examples of physical properties. If we're going to look at the substance, such as elements like neon and oxygens, or even compounds like sodium chloride, you can tell the state of matter that it's in. That is a physical property. We've already talked about color, and two other very important physical properties are melting point and boiling point. For example, physical properties are super important because they help identify substances that chemists are unsure of what they are. A good example of this is if you have a colorless substance and you know that it boils at 100 degrees Celsius and melts at 0 degrees Celsius, it's most likely going to be water because that's the melting and boiling point of water. Okay. So water, 0, and 100. However, if it is something that boiled at 78 and melted at negative 117, that's probably not water. If you look back at our chart, we're going to see that it's going to be ethanol. So let's look back. Here, 78 and negative 117, and yes, it is ethanol. Now that we've covered physical properties, let's look on the other hand, which is chemical. This is the ability of a substance to undergo a specific chemical change, and this is a chemical property. In other words, they change composition. Iron is able to combine with oxygen to form rust. The ability to rust is a chemical property. If you look at iron and it rusts, it changed its composition or its makeup, but you're still able to observe that as being chemical. Other examples of chemical properties include reactivity. So how easily does it combine with other elements? And another one is flammability. How easily does it react with oxygen to form a flame? Chemical properties, just like physical properties, are used to identify a substance. The downfall of this is that chemical properties can only be observed when it undergoes a chemical change or changes its composition. For example, if you were to have a piece of paper and burn it, it's no longer paper anymore, it's going to be ash. Here's our next key question. It says glass is often used to make windows, while copper is often used in electrical wires. What properties of glass make it desirable material to use for windows? The two that pop up off the top of my head are going to be one, that it's clear, or other words, see-through. And the second is that glass is very durable. We want glass to be clear or see-through because that's the purpose of windows, is to look outside. So if we are not able to see through glass, it doesn't serve the purpose. If we were to use copper instead, copper doesn't allow us to look outside. The other thing is glass is very durable. We can add different elements or compounds in it to make it even more durable and resistant to changes in temperature. Glass can withstand storms with high winds. Often it can withstand a lot of hail. It can also withstand storms from the rain and from even snow. This is the last piece of information that we're going to focus on, and it's the states of matter. We've covered states of matter when you guys are a freshman if you take integrated science. These are considered physical properties. You can observe them and it still doesn't change what something is. There are 3 states of matter. A good introductory into the states of matter is just to look at water. Water can be referred to as water, ice, steam, or some people might hear it be called as water vapor. Water is a very common substance and it exists in all 3 physical states. For example, water is going to be a liquid, ice is going to be a solid, and steam and water vapor are going to be gases. This isn't the only substance that's able to do this. Other things can also exist in all 3 states of matter, which are liquid, solid, and gas. So again, the 3 states of matter are solid, liquid, gas. First, we're going to focus on solids. Solids is defined as a type of matter that has a definite shape and volume. Definite means it does not change. The shape of a solid does not depend on the container or room that it's in. For example, a desk in my room is going to have the same shape and volume than if it was in Mr. Hammond's room. Another thing about solids is that the atoms are packed tightly together. They're often in a very orderly arrangement and they're not able to move or slide past one another. This is what gives it its definite shape and definite volume. As a result of this, solids are also considered incompressible. So when things are compressible, it means you're able to squeeze them into a smaller volume. A good example where you've probably heard this word is like compressed air. You can take air that's in a room and squeeze it down into a very, very small, let's say, scuba tank or bottle. Solids, you cannot do this. You can't take a desk and squeeze it down to take up less space. Another thing about solids is that they expand only slightly when heated. Liquids, on the other hand, they're a little bit different. They have an indefinite shape. Means they're indefinite means it changes. And a fixed volume. So fixed is another word for a definite volume. The particles in a liquid are in close contact with one another, but the arrangement of particles in a liquid are not rigid and orderly like you see in a solid. Because they're not as close as a solid, they're free to flow around one another, and this allows liquids to take the shape of their container, or in other words, have indefinite shape. If you put water in a square bowl, it's going to take the shape of that bowl. If you put it in a circle bowl, it's going to take the shape of that bowl as well. However, one thing to note is that volume does not change no matter what its shape is. It's still going to take up the same amount of space. The volume of a liquid is considered fixed or constant. Thus, again, you define liquid as a form of matter that has indefinite shape, flows, yet has a fixed volume. Keeping all of these things in mind, liquids are considered incompressible. It's very hard to take a liquid and fit it into a smaller container. Trust me, if you have a glass of water, you're not going to fit it in a glass that's smaller, unless for some reason it's wider, which means the volume did change. The volume of the glass was the same. So, however, they tend to expand slightly when heated, and that's because some of the liquid turns into gas, and we're going to learn that gases expand very easily. So liquids do expand a little bit. The last one we're going to talk about is gases. This is a form of matter that takes both the shape and volume of its container. In other words, indefinite shape and indefinite volume. Like a liquid, the gas takes the shape of its container, but different from a liquid, the gas is able to expand to fill any volume. For example, if I have a compressed air in a bottle and I decide to spray it, that means those gas is going to spread out and take up the volume of the room instead. So the particles in a gas, the reason they're able to do these things is because the particles are spread very far apart and they're constantly moving. This allows them to spread out from one another. Because of the space between the particles, this also allows gas to be easily compressed into smaller volumes. For example, oxygen can be compressed into scuba tanks to use while diving. The last thing we're going to hit on is gases. And this is more of a terminology. Oftentimes, gas and vapor are used interchangeably. People think they're the same thing, but there is a difference in chemistry. So we're going to just focus on that difference real quick. Gas is used for things like oxygen, which is a gas at room temperature. So notice at room temperature. Often, you should know elements that are gases usually have a red symbol. So oxygen, hydrogen, helium, nitrogen, fluorine, chlorine, argon, krypton are all gases. Vapors, on the other hand, is something that can become a gas, like, for example, gaseous state. But when it's at room temperature, it is a liquid or solid. A good example of this is water. If you look at water and we're at room temperature, it's going to be a liquid. But water can turn into a gaseous state, and that's why it's called water vapor. Here's the last checkpoint question. It says a substance is in a state in which it takes the shape of its container. What state or states could it be in? So let's go back through all of those. Solid, liquid, and gas. Remember, solid has a definite shape and a definite volume. Liquid, on the other hand, has a definite volume, indefinite shape. And a gas has an indefinite shape and indefinite volume. Let's look what it's asking. Which one takes the shape of its container? So takes the shape means that it's going to change. Means this is indefinite. So what is going to be indefinite volume? Well, this one does not count. Oh, indefinite shape. This one does count, so liquid and indefinite shape, gases count. So this can be either a liquid or gas. So liquid or gas. And that's the end of today's lesson. If you have any questions, make sure that you're asking me, and I hope you guys have a very good day.